5-5. We're going to take a look at our trig functions once again, those trig ratios that we talked about just the other day with sine, cosine, tangent, and now we are going to use them to help us find the missing sides and angles of right triangles. So, if I was with you guys in class right now, I'd sit here and say, do you remember how to do this? But I'm just going to go right ahead into the instruction and then have you guys practice a couple. So, just a reminder to you that every right triangle has a specific ratio based off of the angles that we have, and so that 36 degrees is our reference angle that we are looking at. By all means, I could find the third angle here if I wanted to. And with this information right here, I am given the hypotenuse. I know the hypotenuse is 12. And we're trying to find the adjacent side. So when it talks about trigonometry, our ratio that deals with adjacent and hypotenuse is that of cosine. So cosine of 36 degrees is going to equal a specific ratio, which is going to equal that to x over 12. Now, I put cosine of 36 into my calculator. I'm going to get some sort of decimal at this point. It's going to be an irrational number. But we can find the exact value, or a close enough exact value here by using that. Okay, it's just like solving a proportion then. So I've got x right here. Since I'm dividing by 12, I'm going to then multiply both sides by 12, get rid of that, and into my calculator, I'm taking 12 times the cosine of 36 degrees. Hit enter, and 9.71 is the approximated length for what x would be, 9.71. And just by creating that specific ratio. Okay. Trying this one here, I've got another right triangle. This time I have 15 degrees up here. And based off of where the 15 degrees is and the 26 here, I'm given the opposite side. And where x is here, I'm trying to find the adjacent side. So when I look at my ratios here, as far as opposite and adjacent go, we would be using our tangent. And so we've got the tangent of 15 degrees is equal to 26 over x. Now here you just need to be careful because you can't multiply both sides by 26. It's 26 divided by x. So you have to get x out of your denominator first. And so now you've x times the tangent of 15 degrees equals 26. And now we'll divide by the tangent of 15 degrees. And so here's our calculator, and of course it's got 26. So 26 divided by the tangent of 15 degrees, and there we have it, 97.03. 97.03 would be your approximated value for x. And that's going to be based off of that 15 degrees right there. Obviously, if this was a 24, it's going to change the value of x, but the ratio between 26 and 97.03 will be the same thing as if I take 24 and its side as well. Alright, so let's have you try one real quick. Let's put 26 degrees down here. And I'm going to have you, we're going to put an x here, and this side is 19. So why don't you go ahead and solve for x. Alright, so 43.34, using sine for this problem, the opposite and the hypotenuse, and making sure you're multiplying both sides by x. Begin. Alright, I'm going to have you guys try one more real quick. How about, let's let the angle, let's have it be 72 degrees here, and your hypotenuse is going to be 18, and you need to find x. So go ahead and pause it and try and solve for x. Right, so 3.09 using cosine, and I just realized that I did 10 instead of 18. Sorry, 1 second. Let's fix that. I saw that as a 10, so we want to multiply here by 18. Alright, so let's go back. We want to take 18 times the cosine of 72. Sorry about that. So 5.56. Alright, there we go. So that's 18 using that. Right, now you remember how to find missing sides, so now do you remember how to find missing angles by any chance? So, right triangle trig once again, here you're trying to find x, which is an angle, and you do have to have at least 2 measurements given to it. And so here we have x, and we've got the 47, which that right there, there's our hypotenuse, and then the 32 is opposite of that value of x. So opposite and hypotenuse tells us that we'd be using sine. So I can set this up as the sine of x degrees is equal to 32 over 47. How are you going to get the x by itself? You can't divide by the sine, but what we can do is we can do something called the inverse sine. And that's by using the second button on your calculator, and you're going to take the inverse of that ratio. So we're going to take the inverse, the inverse sine of 32 over 47. And what that's going to do is that's going to give us what our angle is going to be. So 42.91 degrees. And there's your angle. The only angle that is going to have of a right triangle that's going to have the ratio of 32 over 47 is going to have to be an angle that is about 42.91 degrees. Okay, here's another one. I've got my x right here, 35, there's your hypotenuse, and the 19 that's given to us here, that's your adjacent side. And so that tells us that we're going to set this up using the cosine. So the cosine of x degrees is equal to 19 over 35. So we can go ahead and take the inverse cosine of 19 over 35, and that's going to give us our angle. So inverse cosine of 19 over 35, 57.12. And here's your angle. Alright, so let's have you guys try one, of course, here. Let's put x in this position here. Let's go 42 here and 27 here. So go ahead and see if you can pause it and find the angle for x. Alright, so how about 32.74 degrees? So there we are for section 5. The one thing that I want to quickly, I'm just looking at my notes here, we should real quick talk about is just angle of elevation, angle of depression real quick. So angle of depression, angle of elevation, it's where you put the angle, which is really important here. So it says, Kristen places her surveyor's telescope on the top of a tripod 5 feet above the ground. She measures an 8-degree elevation above the horizontal to the top of the tree that is 120 feet away. So this is an angle of elevation that's being used. And you've got to realize here that if you want to use SOHCAHTOA, you have to make sure that you're working with right triangles. Now notice that in setting this problem up here, I'm not going to the base of the tree because then that's not a right triangle. We're working with this horizontal right here. And it says that she measures an 8-degree elevation above that horizontal line. We know the tree is going to be 120 feet away. Now, if we're trying to figure out how tall the tree is, here's what we're looking for. Now, be aware that we're going to have to add on this height here, And that's saying that on top of a tripod, that's 5 feet above the ground. So this distance from the bottom to that horizontal right there is going to be 5 feet. But I can solve this triangle now using tangent. So the tangent of 8 degrees is equal to x over 120. And so now take 120 times the tangent of 8. So 120 times the tangent of 8, and we get 16.86. So x is equal to 16.86 feet. But then we have to add on that 5 feet that's working with here. So then really we have 21.86 feet, which is going to measure the height of that tree. Now, taking a look at an angle of depression. Okay, a plane flying at 32,000 feet starts its descent 100 ground miles from an airport. What angle does the plane descend at? What you're trying to do here is you're trying to find the angle of depression. And the angle of depression is when you're looking down at something. So if this plane was to go straight ahead but then look down at it, that is the angle of depression. That's the angle that we're looking for right here. Now, one thing that is interesting here is that angles of depression and angles of elevation are equivalent to each other. They're equal. Those, if you remember back to geometry once again, they are alternate interior angles because you have these horizontals right here that are going to be parallel to each other. So if you want to find the angle of depression, it's the same thing as the angle of elevation. You just have to be careful because too many people put it right here. Okay, and if we do that, you're going to see in a moment here why that wouldn't be such a good thing with this airplane craft here. All right, so a plane flying at 32,000 feet. So there's our height. And begins its descent 100 miles. It says ground miles, so that's going to be our bottom here. Now, one thing that has to happen in order for us to solve this problem correctly is you do have to be in the exact same unit. So you're either going to need to convert it to miles or convert it to feet, whichever one you want to do. Just a side note here that 5,280 feet is equivalent to 1 mile. So I'm going to go ahead and convert the feet, I think, into miles. We'll do that. So if we take 32,000, divide that by 5,280. Now I'm going to want to keep this as a fraction. You want to keep it as an exact answer here. I would get 200 over 33 miles. So I'm getting about 6.06 miles, is what it's roughly turning out to be, but I want to keep it as an exact value here. So now to find our angle, which we're going to use tangent. Tangent gets used a lot when it comes to real world situations because it's hard to measure a hypotenuse, as you can imagine. So our tangent would be the opposite, which would be the 200 over 33. Over the adjacent, which is 100. So we're going to go ahead and take the inverse tangent of 200 over 3 and divide that by, what was it again? 100. Enter. So 33.69 degrees. And there's your angle of descent. Now, that number should be fairly decent value. The reason why I say you want to be careful about, being in this angle right here. If you were to take 90 degrees and minus 33.69 degrees, you're looking at 56.31. That's that's going to be kind of, you're going to feel that one as you descend, that angle. So you want to take a nice gradual descend. So 33.69 degrees would be much more reasonable to do. All right, so I am going to leave it right there. Let me know if you have any questions.